So we are going to, and this is actually like 4.1b, teaching it a little bit differently than last year. Okay. We are going to talk about finding a particular solution. So some of you have been really disappointed that we don't actually get to put a number for C. Okay. However, if we know a coordinate on our function, then we can actually figure out what our plus C value is. Okay. This is called finding a particular solution. We have been finding general solutions to our antiderivatives because in general, it is 1/2 x squared plus C, because there could be an infinite number of possibilities. Okay. So write this down. Let me grab my water. I'll go through it. Extra thirsty today. All right. So our function, we don't know what it is, except for the fact that the coordinate -1, 3 is on the function. And we know its derivative is 4x squared. Well, if we have a derivative and we want to get to the function, what do? We take the antiderivative. Well, that would mean f of x is 4/3 x cubed plus c. Do you agree? Okay. Now, up until now, so like the one day we've been doing this is where we stopped. But now we know that f of -1 equals 3. So we can plug in -1 for x and 3 for y to solve for c. (4/3 -1 cubed). Can we all agree that that's -4/3? Which means we would need to add it to 3. So 3 plus 4/3, 13/3. So f of x specifically is 4/3 x cubed plus 13/3. That's what we're doing today. Isn't it? All right, you think you can do it? And then the third example we'll do together. I have faith in you. Oh no. What? Or what did I mistype? Time out. Do. F of 2. I can't believe you couldn't read my mind like Kylie. your work, neighbors, please.
First of all,
I got
how did you get?
f of x
Oh.
equals
No,
q minus 4
but.
yeah, you have this.
So this is just one, right?
So then it's 2q.
It is indeed just one.
Okay. X cubed minus x plus c. Okay, so f of x is x cubed minus x plus c. Four equals 2 cubed minus 2 plus c. What's c? So you got f of x is x cubed minus x minus 2. One last question. Are you ready? What's different about this one? We start with the second derivative and we need to get back all the way to the function. Yep, one step at a time. We are going to have to go from second derivative to first derivative, and then we can go from first derivative to function. Notice how we have a condition for g prime and g. Okay. Yes. So one step at a time, let's talk about our first derivative. G prime of x is going to need to be the antiderivative of sine of x. Think about it in your head. Think about it in your head. Everybody on 3. 1, 2, 3. You know what I like is that everybody said negative before they said cosine. Okay. All right. Now, whatever. So we know that g prime of 0 equals 1. So if we plug in 0 for x, we should get an output of 1. What is the cosine of 0? The cosine of 0 is 1, which means we have negative 1. Okay, so our first derivative is negative cosine of x plus 2. Now we got to go for round 2. Since we want to get to the function, we need to take the antiderivative of negative cosine x plus 2. Okay. Well, the antiderivative of negative cosine x would be negative sine x, and the antiderivative for 2 is 2x, and then we have our plus c. Okay. Well, we know g of 0 is 6, so 6 equals negative sine of 0 plus 2 times 0 plus c. Yeah. I'm glad I could help you. Okay. I made my job easy. What's c? So g of x is negative sine of x plus 2x plus 6. I would love to scroll back up a little bit. There. Why? Oh, Yeah. He's not wrong. I mean, I don't love the word, but he's not wrong. Okay, so your homework is gonna be fairly straightforward. You have some book problems that are gonna ask you to solve for the particular solution. Now,